All right, guys, this one is the one that we started talking about yesterday in class number 75, growing tomatoes. And we started talking about, we're looking at the true average difference in yield. And we have 10 plots. That's our sample size. And because each plot gets both treatments, right? Okay, and that's variety A versus variety B plants. It is a matched pairs experiment. Anytime we have matched pairs, we're going to assume that the difference is 0, meaning there's no difference. Then we want to try to prove that there is a difference, okay? And we want to try to prove that the variety A plant is better, so it produces more, which means we want a positive number. Okay, so now for the random independence and N. I believe it states in there that not that it's a random sample of plots, but I think it says that it was randomly, each plot was randomly put, like which plant goes first. So let's see. Yes, a coin, not Ross, but a coin toss determines which half of the plot gets variety A plant versus variety B plant. So that's how we want to state it. Random selection, I guess, of treatments to each plot. Independence 10. Now we're going to use 10 pair, we have 10 plots, I guess we can say. So 10 times 10 plots is less than all plots of land. And it's normal. Okay, so we do need to graph, or do we, no, excuse me, we don't need, we would need to graph. However, it doesn't say in this case that we need to graph because it tells us that the graph is already symmetric with no outliers. So we're going to say 10 is not greater than 30. Problem states that graph is symmetric with no outliers. So we normally need to graph, but because we don't have any data, we would either have to assume that. Typically, an AP problem will tell you that it comes from a parent population that's normal, like number 71 or 72, I can't remember which one. Or, okay, or it will tell us that they already graphed it and it's symmetric with no outliers, like right here. Then we're going to go to our method, and our method is a one sample t-test for matched pairs. All right, now we're in the do part. And I already plugged in my calculator, okay? If you need help, just remember that we're dealing with statistics now, right? We don't have data. Okay, so we have 0.34 is our x bar. How do I know that? I know that because it tells us right here. And our SX is 0.83. Okay, now I lost my other screen, so give me a second, I need to pause it. For some reason, my calculator, like, snapshot's not working. So I'll just kind of try to go like this. Now, if you look, we have a t-score of 1.2953. We have a p-value of 0.1137. And then it just gives us our standard deviation and our mean there. Okay, so I want my t-score, I want my p-value, and my degrees of freedom. Why don't you practice just trying to do that on your own, since I've made two other videos, number 71 and number 72. See if you can do that on your own, and I'll help you with the conclusion down here. Okay, so because our p-value is approximately 0.1137, which is greater than alpha of 0.05, we fail to reject HO. We have no evidence that the true mean difference in yield is greater than 0. All right, so there's a little more practice for you guys in this one. Hopefully it worked out, and let me know if you guys have any questions. Have a great day and stay warm.